Alright, I'm going to be introducing some basic statistics stuff. We're going to be talking about sort of the type of table that we'll be dealing with most of the time, frequency, and then cumulative frequency. And then I'll make a second video talking about certain ways in which, basically solving a few cumulative frequency problems. So, to begin with, let's come up with a fake made-up study to analyze the imaginary data for. So I'm going to say this study, so let's write down what this study is about. Study. It's about the number of bristles on toothbrushes. Well, on a toothbrush. Basically, in this imaginary study, what we do is we accumulate a bunch of toothbrushes, and then we go and count the bristles on each one. And I have now received some imaginary data from this study here. So what we're going to do before we create a table that will represent this data, we need to first come up with this variable to represent the number of bristles on a toothbrush. And I'm going to say let t, so I'm going to call it t, equal the number of bristles on a toothbrush. Now, there are two ways in which we can represent this data on the table. So we can basically say, all right, how many toothbrushes have 5? Okay, 5, 0. Right, then 6, also 0. 7, 1. 8, 0 again. 9, 2. 10, 25. Like, this is a very inefficient way of doing it, because there's a whole range of numbers of bristles on toothbrushes, and we don't really want this type of data. So here's how we're going to simplify it. I'm going to start off with 0. So here's our table. 0 is less than t. So, and then is less than or equal to 20. So what this means is in this box of our table, so this is a box in our table, and underneath I'm going to leave a space. In this box in our table, the number that goes in down here, which is our frequency, so I'm going to write F for frequency. The number that goes in down here represents the number of toothbrushes that have somewhere between 0 and exactly 20 bristles on them. Now, let's talk about this equals sign. So this less than or equal sign. Yeah, the less than or equal sign. Why is it on this side? Because it could be on either side. Well, we're not going to realistically find a toothbrush that has no bristles on it. So we put it on this side to say, well, it's definitely greater than 0, but it could also equal 20. It could equal 20. There could be a toothbrush out there with only 20 bristles. That's a possibility. So here I'm going to call this row T and this row F. Frequency represents the number of toothbrushes with this that fit within this band of bristle values. So I'm going to say 5 fit that description. Then over here, I'm going to continue this row. Now we start at 20. Now we start at 20 because that's where this left off. Now you'll notice there's no less than or equals to sign here. This is just a less than sign. Why is that? Well, this within this sort of box, this column, a toothbrush could realistically equal 20. We don't want two columns in which 20 exists, because that will double up our data and cause problems. So we know that it's definitely greater than 20, because if there's anything that equals 20, it went into this box. So t is greater than 20 and less than or equal to 40. Now, in reality, you won't always get data that looks this clean. You could have this be 50, but I'm doing this for my sanity because this is an imaginary study and I can make up all the statistics. So down here, let's say you're 20, because you're going to find a bit more within this range. So then let's continue. Let's begin at 40 again. Again, we have the less than sign and not the less than equal sign. And this exists here for the same reason that this exists here. 60. And actually, I'm going to make the final box as well. 80. So we're going to go up to 80. All right. So I'm going to say there are 40 here and then 5 here. Okay. So now we have our data. We have sort of the range of values. And then we have our frequencies. Now there are 2 more pieces of data that we need to know. Okay, the first one is x. Now what x is it's basically the median of each of these ranges, so the exact middle. So for here it's 10, 30, 50, and 70. And that's why I made it so simple like this, so I can just go do all these calculations in my head very fast. But normally, you know how to find the median of something. You add them together, divide them into just the middle. It's the middle of those 2. Now, the final piece that we want to figure out is something called cumulative frequency. So what is cumulative frequency? Well, it's basically, if we start at 0, here, this has 5. So we say, okay, the cumulative frequency is 5. Then the next one is 20. So we just add the previous value to our new value. So now we get 25. And then here we get 65. And then here we get 70. So we just keep adding it to the previous, the new value to the previous value of the cumulative frequency. Now, why on earth would we want this? Well, it's surprisingly useful for finding out little tidbits. For example, let's suppose I were to say, how many of these toothbrushes in this study had less than or equal to 40 bristles in them? Well, I could look at the frequency and go, well, I know that there's 20 that's within this range, and then 5, and then add them up. Or I could just go to the cumulative frequency and say, hey, there, 25. Or if I were to say, okay, how many of the toothbrushes in this imaginary study have, greater than 60 bristles on them? Well, I could go through, I could add all these up and then find the total, subtract it. Or I could just say, well, 70 is my total, so I'm going to write that over there, 70, right? Then I know that 65 have less than or equal to 60, and I'm looking for greater than. So I just take the 70, subtract 65, that gives me 5. And you'll find that's 5, because that's how many have greater than 60 bristles. No. So having done that, having got our 4 values, I'm now going to make a graph. Now there are 2 graphs that I'm going to show you how to make from this table. But first let's focus on histograms. What is a histogram? Well, a histogram looks like a bar graph, but a little different. So I'm going to draw a bar graph. This is our bar graph. Now I'm going to draw the same graph, but as a histogram. Obviously not exact. There, that is a histogram. The difference is in a bar graph, everything is separated. whereas in a histogram, everything is touching. And you might be thinking, that's a purely aesthetic thing, completely useless, don't need it, just use a bar graph, or just draw all your bar graphs like histograms, and no. These are two different things that serve different purposes. Why? Well, in a bar graph, you have one axis devoted to some numerical quantitative data, and then at the bottom you have different objects that have these different values, right? These are physical objects. I could say, oh, student A and student B, right? Whereas with a histogram, what we can actually do is have two sets of this quantitative data and have them on one graph. And these are especially useful for this. And I'll show you why they're touching and the significance of that and why they're so useful for this when we make the histogram. But it's important to know, bar graph, histogram, they're different. Don't confuse them, please. Okay. Now, let's get on to actually making this histogram. What I'm going to do is I'm going to raise this just so we have a little bit more space to work with down here. So, we need a y-axis. So this is our y-axis. Come down here. And then we need an x-axis. And we need to figure out, okay, which are we putting where? Now, I'm going to say that I'm going to put frequency here and t down here. Now, we're not going to do cumulative frequency and x. Those go on the other graph. We're just dealing with frequency and t at the moment. So t is our variable. So I'm going to lay these out. Okay, this is 0. Now, this goes up. We can do it in 5. So 5, 10, 15, 20, 40. Okay, so that goes up to 40, right? We don't need to go any further because our highest value is 40. Right, and then t goes in steps of 20, so 20, 40, 60, and 80. And I'll just add the little bits in between as well. Now this is where the power of histograms come in. T is a range, right? It's a range, which means, so here this is 0 to 20, so that deals with all of this. Now you might be seeing where I'm going. Well, the frequency is 5, and what we can do is make that 1 bar. So all of the stuff within this range is 5, and stuff that has 5 in this exists within this range. So it gives us the power to make a graph involving a whole range of things like that. So then let's keep going. 20, and look, they're touching because this one starts where this one left off. That's why they're touching like that. So there we have 20. So we continue. And again, if this was 50, then we'd just bring it out to here. But there's no need here because I've been nice. Normally you won't find nice people like me when it comes to making these tables of data, though you'll have a 50, a 120 somewhere in there. So then the next one, we're up to 40, our maximum level, our highest value here. And I'll just be shading them in. And then this one down here is 5. And that's a histogram. And it's clean, and it displays this, these two middle rows perfectly because it lets you know the range in which it exists and the frequency, quite simply. Now there's another type of graph. I'm going to draw that graph now. And that graph is the cumulative frequency graph. And that is not a histogram, it's actually a line of best fit, but it isn't a straight line, it's a curve. And I'll talk about the curve at the end there. So what we're going to be using cumulative frequency, and then we're going to be using x. So the two that we didn't already use. So here we have our y-axis and our x-axis. Now normally cumulative frequency goes on the y-axis and x goes on the x-axis, which is very easy to remember. So we have 0. Now cumulative frequency, also goes up in stages of 5, but it's much higher than frequency. So I'll just fill these in now. There, all the way up to 70. And we're dealing with x, which goes in 10, so 10, 20, 30, 40, 50, and wow, 50, 60. Let's just extend this. It's crude, yes, but it works. There, so that's x, that's our cumulative frequency. Now, at the start, remember how I said cumulative frequency, it begins at 0, off there, off the graph, and then it starts at the frequency. Well, we sort of show that by starting at 0 there. Now, you don't always start at 0, but you usually start at 0. So we start at 0 there, okay? Then we go to the first one here, which is 5, so it's way down there, and that's 10. So at 10, we go to 5. At 30, so over here, at 30, we're at 25, so let's bring that over there, okay. At 50, so over here, we're at 65, so we jump all the way up here. And then at 70, we're at 70. That was really easy to remember. So we have these points, and we don't draw a line of best fit. We actually draw a curve, so like this. Now, I'll actually redraw the bottom of this curve because the shape of this curve is quite important in statistics. So this is not what all cumulative frequency graphs will look like with this exact curve, but this is what most will look like. The reason why is because in the middle, like the middle range of your study, you're going to find the most things. So if you look at a box and whisker plot like this, most of the stuff happens here. These are like outsiders, and then you can have outliers which are even further out that you record separately because they're so far out. But most of the stuff happens in the middle, and we can see that there. See that on this graph here. This low increase in frequency here, there's a low increase of frequency to begin with, and then in the middle area, so this is the middle area, oh, there's a huge increase in frequency. So the slope of this tells us the increase in frequency. And then at the top, oh, there's a low increase in frequency. And you can see that here, 5 on the sides and 20 and 40 in the middle. So there's most of it is within this area, not really so much on the outside. And we can actually use this to predict future values. Oh, will there be something with 200? Probably not. Maybe. Don't know. So this is our cumulative frequency graph. And there are quite a few different things that you can, problems you can do and solve with a graph like this. So for example, something that's not on here, like that's not on here, 55 is not on here. I can draw a line across to the graph and then down, and I can approximate sort of the value, the number, the x value that has 55 items in it. 55 on the cumulative frequency, so it's somewhere around there. Normally you'd start here with the cumulative frequency. And you can use this to find all sorts of things like your interquartile ranges and your medians and stuff like that. But we're not going to get into that right now.